Hello everyone, my name is Khalid. I work as a manager analytics in a large enterprise, and primarily my role is to help teams build data ops practices. I do blog under the name Analytica and quite active on LinkedIn within the community. And today we're going to talk about an interesting subject: scaling data quality, which affects data ops practices quite a bit. Before we talk about scaling data quality, I think it helps to understand what problem are we trying to solve. So a typical life of a data engineer starts off with trying to understand someone else's code and add new features to it, which is distributed across different places. Finally, when the feature is implemented or the bug is fixed, then it's time to push it into production, which can sometimes be an ordeal depending on your architecture. Finally, when we do release it, you do have a feeling sometimes there is something that can go wrong, and long behold, you do get issues starting to come from production, which take considerable time sometimes to debug where the actual issue is. The cycle starts again, and this is the core problem which data ops is trying to solve. In this whole cycle, we're spending a lot of time doing a lot of manual practices, processes, not doing things the right way, which makes us do, which requires a lot of rework. And a big part of data ops is definitely data quality, not just implementing it the first time, but scaling data quality. Over the years, I've noticed certain areas which teams need to focus on to scale data quality, and I've put them all in a mind map. That's how I like to visualize things. Um, and today we're going to just talk about one area, which is CI pipelines. Uh, Eventually, whenever I have spoken to teams about implementing data quality or data ops practices, the main challenge I get back from them is that we have a lot of things to deliver and we don't have enough time. And I do understand that, but the research shows, especially in the software engineering space, that any teams that are practicing DevOps are usually high performers, and they are able to implement or release a lot of value in lesser time with quality. And it's not the other way around. So spending effort on data ops or data quality isn't going to take you away from your deliverables, but it's actually going to help you deliver quicker and with quality. And in today's example, I'm going to talk about a very basic CI pipeline that you can set up. And I'm taking an example of a team that can potentially be working on the Azure platform. So it starts off with, of course, a pull request being approved. So for that to happen, you'll need a pull request. Someone releases a pull request, it gets approved through a code review process, and then the CI pipeline kicks off. What is important before this also is all configs need to be part of your Git repo, including any infrastructure that is required as well. Uh, in the analytics space, deployments, you're not usually deploying just one job. It might be multiple jobs deploying at different one platform or multiple platforms. Your warehousing might be a bit different or in the same place. So all of that is a bit distributed. So if you have a manual process in there somewhere, it totally takes away all the gains that you would get from automation. So anything you need to deploy your code has to be part of your source code, or should be in Git. Tools wise, if you are using Azure platform, then of course your CI pipeline, Azure DevOps works really well. You might have your code in repo, and ARM templates can be extremely helpful if you are deploying, like VMs or containers which are outside of, let's say, not Databricks or other resources. ARM templates can be really helpful for that. Not very popular is static code analysis. Now, I understand a lot of in some teams, most of your code might be SQL. There might be some Python or Scala in there, but especially for that part, I think at least code comment to code ratio and looking out for any dead code. These are two things which we can definitely are helpful for analytics teams as well. There are a lot of other things which static code analysis help with, but at least these two would force teams to add comments enough in the code base so that when a person does leave or moves on, or if I look at my code after some time, I can figure out what's happening. Now there are a lot of tools that you can use for that, I've listed just a few. Um, every organization has their own favorite tool, and I think most of the source static code analysis, they operate in the same way. The important step, I guess, would be having small tests. Now, any test that you're writing on your methods, which would be unit tests, should be would kick off right after your static code analysis goes through, and then what I call job level tests. So a unit test is looking after one method, and let's say if I have a project, and inside that project I might have multiple classes depending on if you're using Scala or Python. um, that whole job, you consider that whole thing as one container. You feed it a data frame with all the data set that is required to validate the different business functions, and then you validate the output coming on the other side. Job level tests are, I think, extremely important because those are the building blocks of making sure that we have considered, you know, erroneous or tricky outliers scenarios while building our jobs, and those are usually the primary suspects of why jobs fail in the first place. So I think this step will add a lot of value and a lot of robustness to your data pipelines. As far as tooling goes, there are a lot of tools out there. If you want to build something on your own, you can use PyTest and then build your own libraries. Very much doable. If you want to use off-the-shelf platforms or libraries, Great Expectations is a very common one. There are many others out there as well, and I think you can use any of them, but I think these two are quite common. And finally, the deployment piece. Now, for deployment, I cannot stress this enough. It has to be single touch deployment, which means as soon as these steps are done, your CI tool should be able to deploy anything that is required for your pipeline to run automatically. And I've seen teams, and I stress on this because I've seen teams where they have a portion of the process which is automated, and then there's a part where someone has to manually go in and do something that just kills the whole thing. This has to be completely an automated deployment, single touch deployment, and the ability to deploy on all environments. So you should have confidence enough that the same thing gets deployed in stage and then in prod. And it also helps with with this automated deployment, that if there's something wrong with our config files or in deployment practice, that comes out very quickly. If you do this in an automated fashion, in a manual process, you won't really know. Now again, as far as tooling goes, again, I think ARM templates, if you have resources outside of Databricks, let's say Databricks, if you're using something within Databricks, you're using its own workflows, then that's just awesome. Over the years, they've improved that quite a bit and added a lot of functionality in there. Now it pretty much works quite similar to ADF pipelines, except for the connections, but it's very slick now. And of course, your CI tool could be Azure DevOps. Massive time saver, a lot of help, and I would strongly recommend teams doing this. And this is how we are able to do more with less. Once you have this automation in place, you can easily release features very quickly, since the process is going to be automated for deployment and validations as well, and you will release it with more confidence. If you have any questions, I guess you can reach out to me on LinkedIn as well. Thank you for taking the time to listen to the session.